Hi everyone, it's Mrs. Summer here to talk about Lesson 611, Stoichiometry Day 2. The goal for this lesson is students will be able to convert grams of a substance to moles of a different substance using a balanced chemical equation. Remember to plan your route using your map. So you started with grams of substance 1, going to moles, then we used our mole to mole ratio to get to moles of the other substance, which you can then go to grams or to volume. Here's a real-world example of stoichiometry. Astronauts rely on stoichiometry to determine the amount of fuel needed, gases produced, and other things. Here's one example. Determine the amount of lithium hydroxide required for a 7-day mission in space for 3 astronauts and 1 happy chimpanzee. Assume each passenger expels 20 moles of CO2 per day. So the chemical equation looks like this. The balanced equation looks like this. And so we have to plan for each passenger. So there's 4 passengers. So 4 times 20 mole is 80 moles per day. Then times 10 days. So even though they're only for a week, you plan for a delay of some kind. Not a right way to enter. They got to keep going. We also need to note that only 85% of the lithium hydroxide scrubbers are efficient. So if we have 4 passengers times 10 days that they're going to be on the trip, times 20 moles per day, because that's how much they expend, you need to account for 800 moles of CO2 being expelled on that 10-day trip. So if we look over here, our chemical equation, so we have 800 moles. That's how much CO2 is being expelled into the spacecraft. So 800 moles. And then over here, we have 2 LiOH. So the lithium hydroxide to CO2 is a 1-to-2 ratio. So 1 mole of CO2 to every 2 moles of lithium hydroxide. So since there was 800 moles, so it's a 1-to-2. So if there's 800 moles of CO2, then you must need 1,600 moles of lithium hydroxide in order to clear the CO2. So now we have the grams of LiOH equals 800 moles of CO2, 2 to 1. Then our moles of CO2 cancel. Then our molar mass, so this is our molar mass of lithium hydroxide, and we get 800 times 2 divided by 1 times 23.9 equals 38,240 grams of LiOH. But remember, the lithium hydroxide scrubbers are only 85% efficient. So from that note here, 85% efficient, you can also calculate how much CO2 would be left in the atmosphere at the end of the trip. Okay, so let's try a 2-step stoichiometry problem. Aluminum metal reacts rapidly with aqueous sulfuric acid to produce aqueous aluminum sulfate and hydrogen gas. Determine the volume of hydrogen gas produced at STP, so standard temperature and pressure, when a 2-gram piece of aluminum completely reacts. So what I have to write what I started with, a 2-gram sample of aluminum. Then I'm going to use my next conversion factor because I'm going to go from grams of aluminum, so grams of aluminum to moles of aluminum, then use the molar ratio between aluminum and hydrogen in the balanced equation to go from moles of aluminum to moles of hydrogen, then from moles of hydrogen to volume of hydrogen using that 22.4 liter conversion. So once I have that set up, my grams of aluminum cancel, and I'm left with moles of aluminum. Now, hold on. And my next conversion factor comes from my balanced chemical equation. So I have my 3 moles of H2 comes from here, and my 2 moles of aluminum comes from here. then that means my moles of aluminum will cancel, and at that stage, I'm left with moles of hydrogen. Then I need to go from my moles of hydrogen to my volume of hydrogen at STP. So I use my 22.4 liters of hydrogen per 1 mole. And so my moles cancel, moles of hydrogen cancel. And when I put this in the calculator, I get 2 divided by 26.98 times 3 divided by 2 times 22.4 liters. And I am left with 2.49 liters of hydrogen as my answer. So you try. Calcium oxide is used to remove sulfur dioxide generated in coal-burning power plants according to the following reaction. 2CaO plus 2SO2 plus O2 yields 2CaSO4. So how many grams of calcium oxide is required to completely react with 1.4 times 10 to the third liters of sulfur dioxide?